सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स एंड डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं रिगार्डिंग टू जस्ट केमिस्ट्री वाला चैनल एज फॉर द जस्ट केमिस्ट्री। In previous video we have discussed about the just preparation method of haloalkane regarding to just one of the technique, that is the from alcohol. Today we'll go with the just from hydrocarbon. This is the second technique from hydrocarbon. From hydrocarbons. If we go with the hydrocarbons, then there are alkane, alkene and alkyne. So from alkene, alkene and alkyne, we can get just haloalkane. If we go with the first of all, then we can take just a part as a from alkene and alkyne. From alkene and alkyne. Regarding to this, from the alkene and alkyne, alkene means having the double bond, at least one double bond, and alkyne means having at least one triple bond. So first of all, we'll go with the one of the technique, that is by addition of halogen acid. By addition of halogen acid. This is the most important. If we go with this reaction, then this is the one of the important example of electrophilic, you can say addition reaction. Electrophilic addition reaction. Regarding to this, as a halogen acid, we can take HF, HCl, HBr, HI, and reactivity sequence will be higher for HI. Just you can say hydrogen iodide. If we'll go with the just reaction, then we can take alkene CS2 double bond CS2. This is the HBr. Suppose now the reaction will be as follows. Electronegativity of Br is larger than the H. Due to presence of electrophile, one of the carbon withdraws the shared electron like this. This H plus attacks over here. So here will formation of CH3, CH2. This is the Br. 1 bromopropane. This is the 1 bromopropane. If we go with the just alkyne, then as a alkyne, lower alkyne, we can take CH, the triple bond CH. This is the HBr. More electronegative element is your Br. So here will partial negative charge. Here will partial positive charge. Due to presence of this electrophile, one of the carbon withdraws the shared electron and H will attack over here. So here will formation of CS2 double bond CS. This is the Br. Further, if it will attack again, it will attack of HBr. Then what will be electronegativity of Br is greater than H plus. Here is the asymmetrical condition. So here will formation of Marconi rule. What is that? We'll discuss later. Marconi rule. This is the Marconi rule. So according to Marconi rule, more electronegative part will attach to that double bonded carbon where number of hydrogen is less. So Br will be over here, and here will formation of CH3. This is the CH. This is the Br and Br. Means we can say that here will formation of gem dihalide. Gem dihalide we have discussed having just two halogen atom on a particular carbon atom. If the alkene is, if the alkene and alkyne is asymmetrical, or we can say unsymmetrical, then reaction will according to Marconi curve. This is the Marconi curve and Antimarkconic rule. Antimarkconic Cove's rule. What are they? We'll discuss. This was about the initial part of the just from alkene and alkyne by the addition of halogen acid, and this is the most important for the learning. The reactivity sequence we have also discussed in the previous videos also, means Hi is more reactive. Now the time to discuss about these two important rules or laws, Markovnikov and Antimarkconic rule. So this is the Markovnikov and Antimarkconic rule. What is that? Listen me carefully. This is the Markovnikov rule. Suppose here is the asymmetrical alkene as a propene, and if here is the addition of HBr, then more electronegative part is your Br, less electronegative part is your hydrogen. Withdrawing of electron due to inductive effect will be as follows: minus and plus. So Br will attack over here, and here will formation of CH3CH. This is the your Br, and this is the CH3. Here will formation of two bromo propane regarding to your asymmetrical alkene when there is the use of Markovnikov rule. This is the Markovnikov's rule. What is Markovnikov rule? Here is the explanation. Markovnikov's rule. Markovnikov's rule means during attack of polar molecule on asymmetrical alkene, or you can say alkene or alkyne, more electronegative part will attach to that double bonded or triple bonded carbon atom, where number of hydrogen atom is less. This is the most important. So here is the one hydrogen, here is the two hydrogens, so more electronegative part, Br will attack over here, and that's why I have a formation of 2 bromopropane. This is the most important to know why here will formation of the 2 bromopropane. Here will not just the formation of 1 bromopropane. We can explain it by the mechanism. This is the most important. It was also important in class 11th. First of all, if we go with the just chain initiation step, then here is the HBr. HBr is a just halogen acid. So due to more electronegative, here will H plus and Br minus. In the second step, this is the alkene as a propene. As an electrophile, here will attack of H plus. So what will be? Suppose if here is the withdrawing of electron like this, then H will attack over here. So here will possibility of one of the CH3. This is the CH plus, and this is the CH3. And if withdrawing of electron is as follows, then H will attack over here. So here will formation of CH3. This is the CH2 and CH2 plus. This is called as 1 degree carbocation. Sorry, 2 degree carbocation. 2 degree carbocation. And this is the 1 degree carbocation. and we have discussed 2-degree carbocation. Stability of the carbocation is 3 to 1. Here is the 2 degree, so 2 degree is more stable. That's why it will take part in the reaction. So in the third step, what will be? Here is the CH3. This is the CH plus. This is the CH3. Here is the attack of nucleophile. So formation of here will just 2 bromopropane. This is the 2 bromopropane. So that's why due to formation of the stable carbocation, here will the attack of electronegative element over the carbon atom where the number of hydrogen atom is less. This was regarding to Marconic rule. Read the method properly because of this is too important. Without learning this material, you can't do. And this is especially for the asymmetrical alkene, not another kind of the just other alkene. Now the time to discuss about the Antimarkconic rule. What is that? We'll go with deeply also. So be with me. I'll give you a lot of matter regarding to this chapter and a lot of new thing which is new for you, but this is in your syllabus and which help you in the justice to make the stronger chemistry. Now the time to discuss about the Antimarkconic rule. This is the Antimarkconic rule. Antimarkconic rule, also called as just peroxide effect. Peroxide effect, because of such reaction basically takes place in the presence of peroxide. This is also called as Kharash effect. Kharash effect. What is that? Means if there is this asymmetrical alkene, suppose CH3, CH double bond, CH2, and if there is the attack of HBr in the presence of peroxide, then what will be? Here will attack of more electronegative part. Here will attack of more electronegative part over the carbon atom where the number of hydrogen atom is more. This is the ulta means just reverse of the Marconic rule. That's why it is called as anti-Marconic rule. Here will formation of one bromopropane means here will formation of one haloalkane where just according to anti-Marconic rule it was the formation of two haloalkane. Why the matter is this is the most important, but remember one thing: peroxide effect is applicable only for HBr, not HI, neither HI nor HCl. And according to anti-Marconic rule, more electronegative part during attack of polar molecule, just more electronegative part will attach to that double bonded carbon atom where number of hydrogen atom is more. This was regarding to your anti-Marconic rule. What is the reason? Here's the attack of just more electronegative element over that carbon where the number of hydrogen atom. This can be explained by using the mechanism This is the mechanism which is very important. Mechanism. This is the chain initiation step. First step, we can call it chain initiation step. What is that? If we go with the chain initiation step, then as a peroxide we can use benzoyl peroxide C6H5CO. This is the OOCO and C6H5. This is the benzoyl peroxide. This is very important kind of the peroxide. If we take this kind of the peroxide, then first of all in chain initiation step, it dissociates as follows. This is the C6H5 COOO C6H5. This is the C6H5. Here will homolytic bond cleavage because of it's a peroxide, means dividation of electron will be equally. So here will formation of, you can say, two species as a 2 C6H5. This is the CO O with the 5 electron, means it will be one unpaired electron. If we'll go with the B step, then this C6H5 COO having 5 electron, and this bond dissociates as follows. This unpaired electron share with this, here will formation of double bond, and it will formation of the 2-phenyl free radical. This is the formation of 2-phenyl free radical, like 2C6H5 plus 2 of CO2. Here will release of CO2 gas. This is the phenyl free radical. Now in the next step, what will be, this is the most important. Here is the C6H5. So in the C step, here is your C6H5 free radical. Here is your HBr. So here will again homolytic bond cleavage. This is most important of the HBr. Like this electron will share with this, and it will formation of C6H5, C6H6 and Br free radical. This is the Br free radical. This was about the chain initiation step. This is the most important step, and the name of step is your chain initiation step. If I'll go with the further, then that is the chain propagation step. This is the second step, chain propagation step. Chain propagation step. If I'll go with this step, then this is the asymmetrical alkene CS2. Here will attack of just free radical. This is the Br free radical. How it will be as follows. Just we can draw them as follows. If suppose this unpaired electron get paired with the right electron, then it will for possibility of the first species. This is the CS3. This is the CH free radical. This is the CS2Br. And if the possibility is as follows, if it attacks over the carbon atom and share with this left electron, then it will be CS3. This is the CH, this is the Br, this is the CS2 free radical. And if we'll go with the just free radical, then you can see this is the 2 degree free radical. 2 degree free radical, and this is the 1 degree free radical. 1 degree free radical. This was about the just type of the radical, and if we'll go with the radical stability of the radical, then 2 degree is more stable. In the second step of the second chain propagation step, what will be? This is the use of 2 degree free radical as follows. This is the CH, CS2 and Br. Here will again attack of HBr. So what will be? Just here will again cleavage of bond in homolytic form, and H will attack over here. So here will formation of CS3, CH2. This is the CS2 and this is the Br with the formation of Br free radical. This was about the 1-bromopropane. 1-bromopropane. Now what will be in chain termination step? We will discuss later. But remember one thing, here will the use of In the Markovnikov, it was the use of just a carbocation, and here will use of the free radical, stability of the free radical. So this was about the anti-Markovnikov rule. We will discuss about the third step, chain termination step. Now the time to discuss about the just chain termination step of this reaction. What is that? Listen me carefully. So if we'll go with the chain termination step, then there will be following three steps. This is the second step. Now the third step is your chain termination step. Chain termination step. If we go with the chain termination step, then in the first step what will be? The forming possibility of the Br minus, just Br free radical, we will react with the another Br free radical. Here will formation of Br2, and in the second possibility, the remaining you can say this one 2-degree free radical. This is the CH3. This is the CH free radical. This is CH2 and Br. Again, it will react with the Br free radical. So here will formation of CH3CH. This is the Br and this is the CH2 and Br. And the third possibility regarding to this is your CH3. We can take this free radical. This is the CH2. This is the Br, and this is the another free radical. This is the CH3. This is the CH2 Br free radical. Combined with each other, they forms CH3, CH, CH, and CH3. This was about the CH2, and this is the CH2 Br and Br. The formation of compound will be 1, 2, 3, 4. This is your, you can say 1,4 dibromo, 1,4 dibromo, just you can say 2,3 dimethyl, 2,3 dimethyl butane. So this was about the name of compound and the mechanism regarding to anti-Markovnikov rule. So now the time to discuss about the second part, that is the regarding to alkene and alkyne by addition of halogen. This is the most important reaction, dear student. Why? Suppose this is the alkene. As a alkene we can take ethene. This is the Br2 in the presence of CCl4. Whenever we'll dissolve the Br2 in CCl4, it gives pink color, pink solution. Whenever it reacts with it, then it will formation of CH2. This is the Br and Br. Here will formation of as a gem dihalide. Here will formation of 1,2 dibromo, 1,2 dibromoethane, 1,2 dibromoethane. This is the 1,2 dibromoethane as a gem dihalide because of as a vicinal dihalide because of both halogen atom are present on neighboring carbon atom. This test is also used for the unsaturation. This test is also used to distinguish unsaturation. Why? Because of pink solution of the Br2 dissolved in CCl4, will turn in colorless compound. Means whenever we'll keep any kind of the unsaturated compound in the contact of just Br2 dissolved in CCl4, then it will be disappearing of the just pink color. That's why we can say that that is the unsaturated hydrocarbon. And if there is no change in the color, then we'll say it is saturated hydrocarbon, means as an alkene. Important thing is your here we can use, this is the most important part, here we can use Bayer's reagent also. Bayer's reagent also. What is the meaning of Bayer's reagent? Then we can say just your alkaline solution of alkaline solution of KMNO4 is called as your Bayer's reagent. This is the Bayer's reagent. Bayer's reagent. So what will be the test? This is the ane of alkene. We can take alkyne also. This is the ane of alkene. This is the aqueous solution. That's why here we'll use of HOH, and here is the alkaline KMNO4. Alkaline KMNO4. Again, here alkaline KMNO4 gives the pink color. Solution gives pink color. KMNO4 also provides the nascent hydrogen. So here will formation of CS2, CH2. This is the OH and OH. Alcohol having more than one OH, means as a two OH, then they are known as glycols. And glycols are again as a colorless compound, while this is the pink solution. So pink solution changes in just becomes colorless, then it will be unsaturated hydrocarbon, and if there is no change, then it will be as a saturated hydrocarbon. So this was about the second by the addition of halogen. Now the time to discuss about the third reaction regarding to alkene and alkyne. What is that? That is the allylic addition. This is very important reaction. Third part is your allylic. This is the third part is your allylic addition. Allylic addition. Allylic addition. Suppose there is propene CH3 CH double bond CH2 and temperature is around 770 Kelvin. 773 exact is your Kelvin temperature. Then on addition of chlorine in the presence of, you can take H light or peroxide also. This is the peroxide also. So what will be? Here will again formation of the free radical, means reaction will according to free radical substitution reaction. Free radical substitution reaction. So what will be? It will attack over the CH3 because of the temperature is not sufficient. So this reaction is irreversible reaction. So Cl will attack is over the CH3 and it will formation of allylic halide like CH2CH. This is the CH2Cl, and here will formation your HCl. This is the allylic chloride as a 1 degree allylic chloride. Now the time to discuss this reaction can be used to form just bromide derivatives also by using NBS. What is that? This is the CH3. This is the CH double bond CH2. This is the NBS, means N-bromosuccinamide. This is the CO. This is the CO. This is the N and Br. This is the NBS. meaning and bromo succinimide. What will be? Here will again with the same condition peroxide. Here will attack of just Br over the same CH3 carbon atom. So here will formation of CH2 double bond CH. This is the CH2 and Br. Rest it will be formation of succinimide. CH2 CH2. This is the CO. This is the CO and this is the N and H. This will be succinimide, and this is the again allylic bromide. If we'll go with the just allylic bromide, then allylic bromide also can be prepared by using sulfuryl chloride. What is that? This is the CS3. Again your CS double bond CS2. This is the SO2Cl2 sulfuryl chloride. Sulfuryl chloride in the presence of same peroxide. Here will formation of just similar allylic chloride. So what is that? This is the CH2 double bond CH2Cl. This is the allylic chloride, and rest is your just it will formation of SO2 and HCl. SO2 and HCl. We can say it's a best method for the formation of allylic chloride because both adduct SO2 and HCl will form in the gaseous state. So this was regarding to allylic addition. Now the time to discuss with the next part of the from hydrocarbon, that is the B part. That is the B part, that is very important also because of will take a lot of matter, that is by free radical addition of alkane. You can say free radical substitution of alkane, sorry. This is the B part by free radical substitution of alkane as a hydrocarbon. We can take second part. You have to listen me carefully. This is the alkane. First of all, we'll go with the just example. Then we can take the chlorination of first example. Chlorination of methane. Chlorination of methane. Regarding to it, this is the CH4. This is the Cl2 in the presence of H mu. Here will formation of CH3Cl plus HCl in the first step. Here will formation of the different compounds means in the form of the mixture. Halogen derivative will form. In the second step, what will be again this CH3Cl. Here excess of Cl2 will be used. Again this Cl2 will react with the CH3Cl. Here will formation of CH2Cl2 with the release of HCl. Now again CH2Cl2 will react with Cl2. Here will formation of CHCl3 as a chloroform and HCl. Now I would like to go with the final step. This is the CHCl3 plus again your Cl2 in the presence of same. Here will formation of CCl4 plus HCl. So what we can say that it's not a good method for the halogen derivative because all the halogen derivative will form in the form of mixture. So we can say not good method because because different halogen derivative, different halogen derivative will form will form in the form of mixture, in the form of mixture. This was regarding to just this reaction. If we'll go with the mechanism of the reaction, then that is the very important. This is the chain initiation step. First of all, this is the Cl2. This is the Cl2. In the presence of H mu, here will homolytic bond cleavage. So here will formation of the two Cl free radical. First of all, this is the A step. Now in the this is the A step. Now in the B step, what will be? One of the Cl free radical will attack over the methane, and here will formation of just your CS3 free radical plus HCl. This is the first HCl molecule which is over here. Now in chain propagation step, this is the chain propagation step second. This is your CS3 free radical. Here will attack of Cl2 molecule. Remember one thing, all the reactions are not, any process is not 100% complete. That's why all the Cl2 molecule will not change in free radical. This is the free radical. Some of the remains in the form of molecule also. That's why here will use of molecule. So it will again homolytic bond cleavage like this. Here will formation of CS3Cl with the formation of Cl free radical. This is the CS3Cl. Now in the further step, this can be written as follows: Cl, CS2 and one of the H. This is the Cl free radical will attack over here again homolytic bond cleavage. So it will formation of CH2Cl free radical with the release of HCl. This is the another molecule of HCl. Now in the further step, CH2Cl will be attacked by again molecule like this. It will dissociate as follows. So formation of CH2Cl2 with the formation of Cl free radical means it will attack one time molecule, one time free radical, one time molecule. Now free radical will attack. So this is the CS2Cl2 can be written as follows. This is the Cl2, this is the CH and one of the H. Here is the attack of Cl free radical. So what will be? Here will CHCl2 as a free radical and removal of HCl. Now in the further CHCl2 free radical, here will attack of Cl2 molecule, cleavage, homolytic bond cleavage. So here will formation of CHCl3 with the formation of Cl free radical. Now in the further step, this can be written as follows: CCl3 and this is the H, homolytic bond cleavage. This is the free radical. So here will formation of again the final, or you can say this is the first HCl molecule, this is the second HCl molecule, this is the third, and this is the final HCl molecule. And here will formation of your CCl3 free radical. Now in the further step, CCl3 free radical will be attacked by a molecule having the homolytic bond cleavage. So here will formation of CCl4. This is the CCl4 plus Cl free radical. This was about the chain propagation step 1, 2, 3, 4, 5, 6 and 7 step. Now we'll go with the third step, chain termination. In the chain termination step, the remaining Cl and the possibility of the just remaining is your CS3. They will treat as follows. There may two Cl free radical, then they will change in Cl2. If there is one of the CS3 free radical and one of the Cl free radical, then here will formation of CS3Cl. And if there is two of free radical as a CS3, then here will formation of your ethane. So here will formation of the different halogen derivative in the form of mixture, not only halogen derivative but also alkane and Cl2 also. So it's not a good method for the formation of halogen derivative. Now, if we'll go with the second example regarding to free radical substitution of alkane, then we can take the example of ethane and propane also, and we'll take a lot of question also. What are they? Listen me carefully. And these reactions are just photochemical reaction because of take place in the presence of light. So if we'll go with the second example, we can take, this is the ethane. This is the ethane, chlorination of ethane. Regarding to ethane, this is the CS3. CS3, here will use of Cl2. This is the H mu. Here will formation of CS3, CS2 and Cl. Chloroethane with the formation of HCl. Chloroethane. Chloroethane. But if there is suppose propane CS3, CS2 and CS3, this is the ethane and this is the propane, then what will be on chlorination? Here will formation of H mu, in the presence of H mu, here will formation of 1 chloropropane and 2 chloropropane, CS3 CHCl and CS3 with the removal of HCl. With the removal of HCl, here is the 1 chloropropane and this is 2 chloropropane. 2 chloropropane. This was regarding to your important part of the propane. Here 2 chloropropane due to formation of the 2-degree free radical, it will as a larger product or major product, and this will be as a minor product. This will be as a minor product. If there is the question, suppose, what is that? Suppose here is the dichlorination of propane, then what will be? Means particular propane का monochlorination नहीं कराया, dichlorination करवा दिया इस बार. So what will be? This is the propane, CS3, CS2, this is the CS3. Here is the dichlorination, so 2 of Cl2 in the presence of H mu photochemical substitution reaction. So here will formation of 3 of the possibility. What are they? Listen me carefully. First possibility will be your CS3CH2CH. This is the Cl and Cl as a geminal dihalide by the removal of 2 of HCl. This may be as follows also, CS3CCl and Cl as a geminal dihalide. This is the 1,1 dichloropropane, this is the 2,2 dichloropropane. Another possibility will be for the vicinal dihalide, CS3CH, this is the Cl and CS2Cl. This is the vicinal dihalide as a 1,2 dichloropropane. And if we'll go with the further, then we can take just CS2Cl and CS2CS2Cl as a, you can say, 1,3 dichloropropane as a alpha omega dihalide. Alpha omega dihalide. This is the vicinal dihalide. This is the geminal dihalide. Gem dihalide. So this will be the question, and this is also in the NCERT. So this was regarding to your chlorination of methane, ethane and propane and dichlorination of the propane. Now we'll take another question also. So the another question regarding to free radical substitution reaction. What is that? Listen me carefully. As I promise you, I'll give you a lot of matter regarding to the chapter, each and every chapter. So the question is, this is the C5S12. This is the C5S12 as a, you can say, pentane. You can say as a pentane. It's a question also in NCERT. पर्टिकुलर आपने इसका क्लोरीनेशन करवाया, मीन्स मोनोक्लोरिनेशन करवा दिया आपने, तो यहां आपके पास में पर्टिकुलर पॉसिबिलिटी क्या होती है, एक होगी ओनली वन आइसोमर, another will be three isomer and another will be four isomer. This is the most important question. So solution will be as follows. If we'll go with the C5S12, then there will be three possibility. One of the N-pentane, you can see this is the CS3. Another isopentane, this is the isopentane, and this is the neopentane. For the C5S12. N-pentane, this is the isopentane, and this is the neopentane. These are the just three isomer. He is asking you just on monochlorination, it will formation of one isomer. So for the one isomer, we'll take just neopentane. So on chlorination, neopentane exists four identical conditions like this. So on chlorination, here will formation of only one isomer, that is your CS3, CCS3. This is the CS3 and CS2Cl. You can call it 1-chloro, 2,2-dimethyl, 2,2-dimethyl propane is the first isomer as a one isomer. Here will formation of the three isomer. So for the three isomer, we can take CS3, CS2, CS2, CS2 and CS3. On chlorination, in the presence of H mu, what will be? These are the three isomer as follows. Number one is your CS3, CS2, 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 CS2Cl. This is the 1-chloropentane. Another possibility is your, this is the, another possibility is your, we can take CS3, CS2, this is the CHCl, CS2 and CS3. This is the 1-chloropentane, 1-chloropentane. This is the 2-chloropentane. Sorry, this is the 2-chloropentane. 2-chloropentane. Now I would like to go with the just third isomer. Then we can take over here. This is the CS3CH. This is the CHCl, CS2 and CS3. This is the 3-chloropentane. 3-chloropentane. So this here is the formation of three isomer. Now I would like to go with the four isomer. Then the four isomer we can take. Regarding to four isomer, we can take the example of just isopentane. So first isomer will be as follows. This is the CH3CH, this is the CH2, this is the CH2Cl. Second isomer will be CH3CH, CH3, this is the CHCl and this is the CH3. Third isomer will be your CH3, this is the CH3. You can take over here CH3, this is the CH3, this is your Cl, CH2 and CH3. Now the final isomer will be as follows. This is the CH3 for the isopentane, Cl, CH2, this is the CH3, this is the CH2CH3. The name of compounds are just 1-chloro, 3-methyl butane. This is the 2-chloro, just 3-methyl butane. This is the 2-chloro, 2-methyl butane. This is the, you can say 1-chloro, 2-methyl butane. So here are the formation of the four isomer. For the normal isomer, it will be 3 isomer. For the neopentyl, neopentane, it will formation of the 1 isomer. This is the most important regarding to NCRT. Now I would like to go with the another example. What is that? Listen me carefully. That is too important. How? It is another question for the CBSE or NCRT book. What is that? There is one of the hydrocarbon having the formula C5H10, C5H10. On monochlorination in the presence of, you can say, light, here will formation of only one isomer. Only one isomer. What is that? Write the suitable reaction or appropriate reaction. So regarding to this formula, it will be just two of the isomer, one of the pentene, and they doesn't undergo just free radical substitution reaction. If we'll go with the C5H10, then another isomer will be your CS2. This is the CS2, this is the CS2, this is the CS2, and this is your CS2. This is called as cyclopentane. This is called as cyclopentane. This is again your alkane. So on monochlorination, what will be? On monochlorination in the presence of light, it will free radical substitution reaction. So here will formation of only one isomer that may anywhere. That will be as a chlorocyclopentane, like this. This is the CH, this is the Cl, chlorocyclopentane, chlorocyclopentane with the removal of HCl. And here is the just only one isomer. One isomer. This is the photochemical substitution reaction also. If we'll go with the just free radical substitution reaction of the alkane, then if we want to get just iodine derivative, then it is not possible by the direct reaction because of we have to take, because of it's a reversible reaction. So again it will formation of the I2. So what we can say? We can say that for the iodine derivative, for iodination भी कह सकते हैं just for iodine derivative, it will use of oxidizing agent ताकि reaction reversible ना हो. As an oxidizing agent we can use HiO3 or HNO3, nitric acid or iodic acid. If we'll go with the reaction, then this is the suppose CH4, this is the I2. Here will formation of CH3I, and here will formation of HI also. This HiO3 absorbs to the, this HiO3 absorbs to the HI. This is the HiO3 absorbs to the HI in the ratio of 5:1. Then here will formation of again, what is that? This is the 5 and 1 6, so 3 of S2O, 3 of S2O, and it will just hydrogen we have used 3 of S2O, and rest it will be 5 and 1 6 I2. This will be 6I, so we can say 3I2. So by using this reaction, by using HiO3, we can just get the just iodine derivatives. If we want to fluorine derivative from this reaction, then fluorine derivatives are not possible, not possible from this reaction, from direct reaction, because of, we can say, here fluorine is 2 electronegative and it exists just explosion. So what we can say here, if you want to get just fluorine derivative, then either you have to use F2 in the presence of either N2 atmosphere, yeah, just argon atmosphere, then here will formation of CS3F plus HF. Otherwise it is not possible. And another method, by using Schwarz method, that is Schwarz method, we'll discuss later. By using Schwarz method, you can get the just fluorine derivatives of the alkene. So this was about the regarding to just from hydrocarbon. So we will meet in the next video with the just another techniques of the just preparation methods of the just haloalkane. Till then, shukriya, dhanyawad.